So let me introduce our next speakers. Yoon from Sheffield and Eno from Mediap and Thomas from INESC will talk about future perspectives on pathological speech recognition.
Okay, good morning. So I would like to share a bit our thoughts and perspectives of what we think is going to be the next kind of hot topics and issues related to pathological speech recognition broadly. So some things we touched upon yesterday already in terms of the current challenges that we're facing, that we're mainly working with very small research data sets that are limited to a few pathologies only with few speakers. So it's hard to do certain things with them, and will cause issues of overfitting as well when we're just like hacking our systems to work well on these few data sets. They're often limited to isolated words as well, and were not originally designed for speech recognition. So it's not necessarily the most realistic data sets for these tasks. And then in general, can currently achieve good speech recognition results, mostly for mild to moderate cases of dysarthria or other pathologies, and still a long way to go to work well for severely dysarthric speakers. So in terms of research, some things I will think will be more important in the future will be larger task-specific corpora for speech recognition specifically. So there's a few new ones recently, like the EasyCall and IDEA Italian pathological speech data sets. Just it came out last year, specifically collected for speech recognition, and include a few more speakers, and hopefully there'll be more of these in the future as well. Data augmentation kind of has been something that's been important for a long time already, but I think we'll continue to see that with the advances that we see in voice conversion, speech synthesis. So that opens up a lot of possibilities. Then self-supervised learning, as we saw yesterday, performs well on a lot of tasks and will probably be increasingly incorporated into pathological speech recognition, as well as the basis for fine-tuning models, for example, and also meta-learning. So starting from a pre-trained model, then learning how best to adapt and fine-tune that to new speakers. If you want to add anything.
Yeah, so this part I just want to add also the tasks beneficial representation learning. And I think this means because nowadays people use like mainstream handcrafted features at the MSCC and then FBank, and maybe add speaker adaptation, have MLR, etc. However, these features, they have a standard like processing procedure. We don't really know like how like what information has been lost, which is maybe like beneficial to this task. And lots of people, lots of researchers, they are now like learn representations through the neural network. But however, I still think this is kind of a black box. Like neural network can help us to learn the representation which is related to our final like objective, but it's like it's need to be interpretable. And I think there's also one method. So we look into the signal processing, this field itself. So for example, we have already have some research like doing the source filter modeling and real imaginary parts. So I think if we look back into the very basic stuff to learn the representation, to know why this features work. For example, this helps to normalize the speakers and by visualizing the filters or something else. So I think this is also one very important research perspective. Do you have anything?
Just like we can also add the multitask and the multimodality, which are getting more and more interest recently. So where the idea is, instead of having just speech, you can use other modality. So it can be cameras, it can be videos, it can be even like HG or other modalities.
Yeah, so already mentioned this yesterday as well, but we're starting to see some interest from large tech companies as well in this areas for a long time. I think it was like we're not interested in that. We're just working on speech recognition in general, but not targeting pathological speech. But this has changed. And one notable example is probably Google's project Euphonia. If you haven't heard of it, might want to look that up as well. So they've been doing very large scale data collection with more than 1,000 speakers, more than 1,000 hours, many different pathologies. And I think branching out into languages other than English now. That opens up a lot of possibilities, but then this is also a closed data set that's not directly available for other researchers. For us, there's currently no direct benefit other than seeing their outputs. Hopefully there will be some open alternatives to that, for example, through Mozilla's Common Voice project, where people can share their data, and maybe that could be a possibility to include more pathological speech as well on a larger scale. And with these ones, we're seeing some kind of dramatic improvements in word error rates, where first they can do evaluation on a much larger set of speakers, but also seems some of that just comes from the fact that they're pre-training the model on very large data sets of typical speech in general, because they have a lot of internal data for that as well. So the scale of the models in general, not even for pathological speech specifically, is much larger, which is also not directly accessible to a lot of research labs, but possibly with like pre-trained models, we can get some access to that in the future as well.
Yeah, like for the clinical perspectives, as Anno said, we can do some software or application for pathological speech therapy. Therapy box people didn't come today, but they have a very like fancy application named Predictable. So because I had my internship there, and I got to get the chance to use the application. It's very fancy, so you can use like eye tracking, or like even by our so the just to move our head, or like to wink, even to like choose which letter you have, and then they will have like some candidates word or phrases, so they people who cannot talk, but they can use their facial expression or the movement of their head to speak with, like, communicate with others. And it's the application itself also have like the TTS system. It can the application can speak out what you want, what you want to say. So yes, so I mean for a clinical perspective, we can like make the software and even wearable devices or the application on the iPad or PC. That will be really helpful. And I think Thomas maybe have more thoughts on this because he is working on children's speech. Yeah.
Yeah, like there is definitely like a huge interest recently on like at least for children with pathological speech, and especially because now when like typical like even when we get collection of typical children, there are still some people that still try to put like a pathological speech. So when there is huge data collection, they still want to have pathological speech, at least for children. I think about there is like recently an Australian data set of 600 hours for children, only for children, and they really really insist on the fact that yeah, we have pathological speech in it. That's super important. So yeah, there is a gaining interest, definitely.
Yeah, that's it from our side, and then I guess we can get into a discussion later this afternoon. So note down any questions that you have for later. Thanks.
Thank you, guys. So, yeah.